What we're going to look at today is about waves, and in particular about what's called the wave equation. So, in 1 second, there are how many waves that pass a certain point. This is the frequency of the wave. So let's say f waves pass a certain point per second. So let's say 2 waves go past, the frequency is 2 Hertz. Let's say each wave has a wavelength of lambda. So you've got f waves passing, each wave has a length of lambda. So the distance it travels when f waves pass in 1 second is basically going to be f lots of lambda. So basically the distance travelled per second is f times lambda. Now the distance travelled per second is also known as the speed or the velocity. So the velocity is equal to f lambda. So the distance travelled per second is equal to f lambda, and that's what the velocity is. So this is called the wave equation. V is equal to f lambda. Let's look at an example of this. The speed of the wave is equal to the distance travelled per second. The frequency is equal to the number of waves generated per second, number of waves that go past you per second. So let's say if 5 waves pass per second, in other words the frequency is 5 Hertz, each wave has a wavelength of 20 centimeters. How far does it travel in that second? Well, basically in 1 second we get 5 waves of 20. So V is equal to f lambda. V is equal to 5 times 20 is equal to 100 centimeters per second. This will be the speed of the wave. Some other things are the energy rules. A wave has a greater energy if it has 1 or 2 conditions. If it has a higher amplitude, if the wave is higher, the energy of the wave will be greater. You can say that the energy depends on the amplitude squared. Also, it has greater energy if it has a higher frequency. So there's radiations with high frequencies like gamma rays and X-rays and even ultraviolet. These pack a lot of energy because they've got high frequencies. Now, which one of these 2 waves carries more energy? Is it wave A? Is it wave B? Or do they both have the same energy? Now we have to look at basically the amplitude and the frequency. Now if you compare the amplitudes, the height of the wave, that's basically the same. So it depends on the frequency. Now A has a very short wavelength. There are many that pass in a second, so it's going to have a high frequency. So the one that has the highest energy is equal to this one, basically because it has a high frequency, and the one on the right, B, has a low frequency because it's a very long wavelength. Notice that this equation V is equal to f lambda. If the velocity is constant, if it has a long wavelength, it's going to have a very small frequency. If it has a very short wavelength, it's going to have a high frequency.